So I'm showing in red a strophoid, which is defined by the position of its node, a point F, okay, that I can move around here, okay, and the direction of a line that passes through N known as the asymptote, okay. So these two branches of the strophoid eventually are going to become parallel to the asymptote at infinity, okay, but that's not germane here. Now, a very interesting remark is that, let me try to make this guy a little more like that. A very interesting remark is that the N-antipedal curve to the strophoid is a parabola, okay, whose focus is a reflection of N about F. You get G, that's the focus of this parabola, the magenta curve, and whose directrix coincides with the asymptote. Okay, so these two curves are interrelated. Now let me very quickly review what the N-antipedal curve is. I'm going to take the point N, previously defined, okay, and a point P that is variable on the strophoid. Okay, so I can move this point P on the strophoid around. It's just a construction point. I'm going to draw the segment NP and compute its perpendicular. N-antipedality means that the N-antipedal curve is essentially the envelope of these perpendicular lines over all P on the strophoid. So you get a parabola when you do that. Conversely, you could say that the strophoid is the N-pedal curve of a parabola. You take a parabola, any parabola, and then you just take a point on it, okay, compute a tangent at that point, okay, and you have a reference point N. Now you want to drop a perpendicular from N onto that tangent and compute its foot P. So the strophoid will be the N-pedal, okay, which is the reverse operation of the antipedal, right, of the parabola. Okay, so you're playing with tangents here to the curve. Very good. Now, what's another thing that unites these two curves is the fact that the focus G of the parabola is a reflection of N about this magic point F. Okay, the focus of the strophoid. On previous videos, we defined what the focus really does in terms of the shape. In this particular GeoGebra app here, I can move F around, I can move the asymptote around, etc., etc. Very good. So we have two curves, strophoid in red, and it's N-antipedal parabola in magenta. Now, here's the focus G. Another thing that unites these two curves is the fact that the directrix to this parabola will coincide with the asymptote. Okay, so if you're playing with GeoGebra, you can basically build a parabola by just defining its directrix and focus. Okay, and in fact, this is how I built this curve here, right? Because I can get G by reflecting N about F, and I can just use the asymptote as my directrix, and then GeoGebra will draw a parabola. Now, the main subject of this video is these 2 points here. V, the vertex of the parabola, which is the midpoint between G and this foot here on the directrix, okay? And this point Z, which is a single point of contact between the strophoid and its N-antipedal, this parabola. Okay, so there's always a single point of contact, which is an interesting remark in itself. And this at this point of contact, you can see here that the tangent to the parabola is perpendicular, exactly perpendicular to NZ. Okay, so that's a special point there, like a critical point of this map, as is V, right? Vertex of a parabola is also a critical point. So one thing that we notice as we're playing with this system, and let me see if I'm centered, is the fact that there is a circle, which we're calling the wedding ring, that marries these two curves. And a diameter of the circle is a segment that unites the two foci. The focus of if you draw the segment that unites the focus of the strophoid to the focus of its antipedal, N-antipedal curve G, this parabola focus, okay, this is the diameter of a circle that magically passes through V, the vertex of the parabola, and Z, their point of contact. Okay, this has not been proved yet, but we thought this was a pretty harmonious, find. You can see here that the radius of the circle doesn't change if I only change the direction of the asymptote, and the reason is that the segment FG doesn't change since N and F are fixed, so you get G by reflecting N about F. So if I just play with this degree of freedom here, nothing happens to my circle. And you can see that both V and Z, the vertex and that point of contact, they will just move rigidly through that wedding ring, okay, so to speak. The way to get different radii is by changing the distance between F and N, okay? And then you get different radii because the diameter of the circle is basically FG, okay? All right, I think that's all I have for this video, and I'll see you on the next one. Bye.